All right, so this is going to be a video about polynomial graph characteristics. This first video is going to be about finding the sign of the leading coefficient of polynomials, as well as determining the lowest possible degree for each polynomial based on the graph. Okay, so this first one, you can see that it's linear, and because it's linear, there's only one solution right here for this graph, so that's the one. There's one X-intercept right there. If you notice, there are no relative extrema, so if you do the relative extrema rule where you add one to it, it basically tells you the lowest possible degree for that polynomial. This one has 0 relative extrema, and then you just have to add 1 to it, and this will tell you the degree of the polynomial. Okay, so the degree of this polynomial is 1, which means the parent function of this is going to be y equals x to the first. That's what that 1 represents. So that's why it is linear. Okay, the other part says find the sign, positive or negative, of the leading coefficient. And if you notice, it is going down as x increases. So because it's going down as you go from left to right, it is going to be a negative sign. So I'm going to write negative for this one. So it's got a negative leading coefficient. Okay. The next one, you can kind of see that it's quadratic, or you can apply the relative extrema rule on this one. There is one relative extrema, and you have to add 1 to it. So the relative extrema is right here. Okay, it'd be a relative max, and that means that the degree of this would be 2, which makes sense because the parent function of this is going to be y equals x to the second power. Okay, so it's quadratic. It is pointing down, the quadratic equation. The quadratic graph right here is pointing down. Also, from going from left to right, it is decreasing going this way. So then again, it's going to have a negative leading coefficient. All right, this next one, it's got real solutions here, here, and here for the X-intercepts for this graph. And there are 3 of them. So that's one way of looking at it, that it's going to be x to the third. So it'll have a degree of 3. Another way you can do it is if you look at the relative extrema, there's one relative extrema here and there's one here. So that would be 2 plus 1, because you always have to add 1 to the relative extrema, and that does tell you the degree to be 3. So there are multiple ways of looking at these problems. Now, as you go from left to right, up here it's going up. So because of that, it is going to have a positive leading coefficient. If you remember, when it's negative, it points down as you're going from left to right. Here it's pointing up, so it's positive. Okay, if you notice the other ones, they are pointing down. For example, that first one, it's pointing down. This one, it's pointing down, so it's negative for those 2. Okay, let's move on to the next one. Okay, here we have no real solutions for those X-intercepts. It does not intersect the X-axis anywhere, which is totally fine, because what we can do is use the number of relative extrema. So we have a relative extrema here, here, and here, and we can find the lowest possible degree for this polynomial that way. So there's going to be 3 of those, and you just add 1 based on the relative extrema rule that we have, and you're going to end up with 4 for that one. Okay, and again, as a review, you just count how many relative extrema there are, and then you add 1 to it. That will tell you the minimum degree that you can have for the polynomial of the graph. All right, and it is pointing down as we go from left to right, so that means it is going to have a negative leading coefficient. Okay. And this last one, it only has one real solution right here, so that doesn't tell you much about it. We are going to have to use the relative extrema rule for this, and we have 1, 2, 3, 4 relative extrema. But remember, the rule is you have to add 1 extra to it, so that ends up being 5, so it ends up being 5th degree on this, which means the parent function is going to be x to the 5th, plus a bunch of other stuff for the actual equation, but the parent function will be to the 5th power. And because it is pointing up as we go left to right, as x goes to infinity, y is going to infinity, it is going to have a positive leading coefficient. All right, so those are some practice problems involving the graphing characteristics of polynomials. If you notice, I'm only asking for the sign of the leading coefficient and the minimum degree that it could possibly have. The next video, we're going to go into a deeper dive into the x and y intercepts for the graph characteristics. So if you have any questions about anything in this video, let me know.